Well, here we are at the end of the last module, and so there has been a lot of material in this chapter, no doubt about that. As you're going back and reviewing, try to notice the similarities in the things that you're studying. Notice the similarities between aldehydes and ketones. Notice the similarities between esters and carboxylic acids. Okay, notice the similarities between alcohols and ethers. Those are the classifications where you're going to see the most similarity. So I'm going to repeat those one more time. Notice the similarity between an alcohol and an ether. They both have singly bonded oxygens. Okay. Notice the similarity between aldehydes and ketones. They both have doubly bonded oxygens. Notice the similarity between an acid and an ester because they both have a doubly bonded oxygen as well as a singly bonded oxygen. So notice how those group together and how they're similar to each other. Now he talked today in your reading about carbohydrates. I'm not going to spend a lot of time talking about that. What I'm going to spend time on today is I'm going to try to summarize all the reactions that we've talked about because they may be kind of swimming around in your head by this point as well. So if we can group them together into similar ways, I think that is going to help you to be able to keep everything straight. We first started talking about an addition reaction. And addition reactions happen across either a double bond or a triple bond. And one of two things is going to happen. Either you're going to form a saturated hydrocarbon, a lot of times it's just going to be an alkane, or you're going to form an alcohol, depending on what you're adding across that double bond. If you're adding hydrogen, then you're going to form the saturated hydrocarbon. If you're adding water, you're going to be forming an alcohol, okay? Now, your dehydration reactions, if you remember, because I think I've put almost all of those up on the board, you can always draw a box around an H on one side and an OH on the other side. And when you pull that water out, whatever's left over links together. And so primary alcohols, if you have two molecules of those are going to dehydrate and you're going to pull a water molecule out and you're going to make an ether. An acid and an alcohol are going to dehydrate to make an ester. Amino acids dehydrate to make proteins, and as you read today in your book, monosaccharides are going to dehydrate and link up to form polysaccharides. So whenever you have a dehydration reaction, you're pulling a water out, but you're enabling other things to link together. Okay, the alcohols are linking, the acid and the alcohol are linking, the amino acids are linking, the monosaccharides are linking together. So in all of these dehydration reactions, you're taking smaller molecules, you're pulling out water, you're linking them together to make a bigger molecule, okay? Ethers have that oxygen bridge in them, so they are holding together two smaller pieces. An ester, remember we talked about how if you use your hand to make an L, you're linking whatever's over here by your thumb with whatever's over here on this side. So you're linking those two things, linking the amino acids, linking the monosaccharides together. So dehydration reactions link things together by pulling out the water. Now, the opposite of a dehydration reaction is a hydrolysis reaction. Now, in theory, a hydrolysis reaction, you could take all of these and flip them around, add water to them, and you turn an ether into the primary alcohols. But the only one that the author is really concerned about, and the only one I'm going to be concerned about as well, is that you know that if you take polysaccharides and you conduct a hydrolysis reaction, you can turn them into monosaccharides. And you were able to do that in that last lab that you did in this particular module, okay? Or maybe you're doing it tomorrow. I have that backwards. Okay, now the other type of reaction that we talked about was the oxidation reactions. And so in all of those, somehow we're adding an oxygen bond in all of the oxidation reactions. That's the best way to remember that. So a primary alcohol turns into an aldehyde. A primary alcohol has a single bond to an oxygen. An aldehyde has a double bond to an oxygen. So we're adding an oxygen bond. A secondary alcohol has a single bond to an oxygen in the alcohol group, but then a ketone has a double bond to the oxygen. So again, you're turning something that has a singly bonded oxygen into something that has a doubly bonded oxygen. An aldehyde and a turns into a carboxylic acid when it's oxidized. Now, both aldehydes and carboxylic acids have a doubly bonded oxygen, but a carboxylic acid has an additional oxygen bonded to it. Okay, so in all of these situations, we are adding an additional oxygen bond, whether it be to the existing oxygen that was already there, or whether we're just going to even add a whole nother oxygen as when I turn an aldehyde into a carboxylic acid. Okay, so as you're going back and reviewing the chapter and as you're studying, really try to group the similar things together in your mind so that you will be able to keep everything straight as you're trying to sort through it all and prepare for your test.